Hello, hello. Happy Thursday, everybody. How you guys doing? Just trying out some different music here for the intros. I've got a buddy who's in a band, and they said their music wasn't DMCA protected, and they said people could use it for free. So I was like, oh, cool. We'll try it out. So it reminds me of a lot when I was younger. It makes me feel old, but that's okay. All right. Yeah, happy Thursday. Hope you got your coffee. Yeah, mine here. We're good to rock and roll. All right, we got a couple things on tap today. Take a peek. Let's take a peek. I got all those project ones to grade tonight too. That'll be fun. All right, let's got our schedule. I think we're doing well. So we've got chapter 9, which is all about wrapper classes and text processing. So just some miscellaneous topics. A lot to do with strings here in chapter 9. Don't forget the chapter 8 quiz is coming up due tomorrow, 11:59 p.m. So do get that one in for me. And then I'll post the chapter 9 quiz a little bit later tonight. And again, probably about next Friday or so for that. And then we'll move on to inheritance. We're going to camp here for 2 weeks, look at some interesting stuff in chapter 10 about inheritance. Yeah, I mean, an extra day is no problem. And if that makes the schedule work better. If you need to get it in on Saturday, I can usually take it a little bit late, but do ask me ahead of time. Don't just assume I'll take something late, because it's not like I've gone over the answers right away, but the deadlines are there for you guys to stay up to date. Right? I give the quizzes to make sure that you're reading the chapters and following up in the textbook instead of just listening to me and hoping you're going to get enough information out of it. Because I hate to tell you, but you're not going to get enough just listening to me. Right? You got to put more effort into it. I'm looking for my charger here. I don't know what happened to it. Huh. Weird. I actually had it right here on my desk. Too much stuff up here. That's all right. Cards back. That's okay. All right. Yep. So, chapter 9. It should go relatively quick tonight, but I do want to spend a little bit of time talking about the project 2 as well. Give you guys a couple little pieces there that might be helpful. So let's start with that, and then we can jump into chapter 9 content. And where did that charger go? It's crazy. It's all right. All right, let's see. Let me start up a new project for you here. Let's do Java application, Java with Ant. Right, we got the right directory. This is chapter 9, evening. And we can go from there. All right, while that loads, let me pull up my GitHub here. Okay. And we're going to take a peek at these. So we talked a little bit about enums before, right? And part of chapter 8, these enums. We said, hey, you could have a day of the week, a time of the day, that sort of thing. Right, so, excuse me. What I want to show you, let's add another class here. And let's just call this one card. I just want to show you how this might work with a card class. It's not everything I'd expect you guys to have, but that's okay. So again, cards should have enums for face and suit. Right? I'm going to do this a little bit differently. This is not, just an example, not the real card class. Just want to show you how this might work well. Okay, so we've got a card class. Maybe we have a int for face value, or just call it face. Sure, why not? And maybe I'll have a constructor then that takes an int for face. Again, still have to deal with suits and all those sorts of things and use enums. I just want to show you ints because they're fast right now and not do all of it. So I'll say this face is the face you give me. Then what I want to do, if I have a list of these cards out here, okay? Let's see. So let me make, say, I will just make a card array. Cards equals new card array, and we'll give it some value. So here's a card of, or new card, say of 2, a new card of 5, and then a new card of 7. Something like this, right? So we'll just create an array, put some new cards in it. Oh, what did I miss here? New card. Int. Card. Int. Required no arguments. Did it not? It didn't save. Okay. I think my project's not set to save. Let me go back. It's compile on building, I think, is the worst. I think that's a problem. Yep. Okay. So it didn't actually know about card until I told it not to do that. I don't understand why it does that, and it's irritating. But okay, so sure, I'm going to put a couple cards in here. And then let's do a new card, say of like 3. Or well, let's do all 5, right? Because you'd have 5 cards in your hand. And this isn't how you go about it, but I just want to show you an example. And let's put in maybe a 4. Okay? Or we can do a duplicate. Let's do a 3. So that we have 2 cards with the same face. That's allowed. Okay? Just adding some cards. Now, if I were to print them out, right, we need, let's add a little getter here. So insert our getter. Nope, not a logger. That was the wrong thing. Insert a getter. Insert a getter. Base. Okay, so we'll loop through cards. We'll say for card in cards, right? With this little enhanced for loop, we'll just print out the card.face, card get face. Okay, we'll get out that integer value. Get face. All right. And oops. Let's see. Okay, and we'll see what we get. Right, we should get them in the order we created them. Right, a 2, a 5, a 7, a 3, and a 3. See if that goes. Come on. Let's go, Java. There we go, 2, 5, 7, 3, 3. Now remember, when we talked about the project, we said it's going to be a lot easier for you if you have them sorted. Right? If you keep them sorted, actually low to high, not high to low, but either one is fine. Just know which direction it sorts. Will be a lot easier. And we could manually sort them ourselves if we wanted to, but like in your hand class, your poker hand class, it should just take 5 cards and it should then go sort them. It turns out we've got an easy way to sort things. So if I just had an array of integers, numbers, int array, numbers, with new int array with 2, 5, 7, 3, and 3, right? We could do the same thing here. So for int number, and numbers, we'll print out just the number. Right, we're going to get the same ordering. So again, we'd have to sort, but there's an easy way to sort integers. To do that, you call arrays. So we have to import that from the library. So it's java.util.arrays. You call arrays.sort. We can sort numbers. And then we can print the numbers again. Okay, and then we're going to get them in order. So this is the we'll print. This is numbers pre-sort. This is sort, and then this is numbers post-sort. Let's not bother with the cards one for now. I just want to show you just the numbers. When we run this, they're going to be sorted, right? It should do what we expect it to do. So sort by default will give us the ascending order from low to high. Okay, so post-sort, 2, 3, 3, 5, 7. So pre-sort, right, they were 2, 5, 7, 3, 3. And after we sort, they're in nice order. Well, it'd be cool if we could sort our array of cards, right? So this is cards pre-sort. Wouldn't it be nice if we could say arrays.sort sort cards? Sure, it's an array. We can sort it, right? And then we'll do this post sort. And let's run it. Let's see what we get. Oh, uh-oh. Class cast exception. Card cannot be cast to class. Java.lang.comparable. Comparable, yep. Can't compare them. There's no compare to. Okay, well we can fix that. So we haven't talked much about it. I think we'll get to it in chapter 10. We talk about inheritance and more about classes and other cool stuff. But we can say we want to implement, that's technically an interface in Java. So we're going to implement comparable. Implement, make sure I can spell that right. Implements, there we go, comparable. And we are comparable of type card. Oops. Okay, and this tell me, oh, wait, there's a problem here. Oh, is it not? Did I spell it wrong? No, comparable. Comparable. There we go. No. No. That's comparable. You don't want any of those. That's not right. Where's the comparable here? Why is that not giving it to me? Comparable. Should just be in there. Let's compare. There we go. Comparable. I must have been spelling it wrong. Okay. I probably don't know how to spell. Anyway, now that we have this here and it's spelled right, it gives us a red line. It says, hey, card is not abstract, does not override abstract method compare to card. Right, so that's the trick here is we need a method called compare to. So we have to implement that abstract method. And we'll talk more about that in chapter 10. Don't worry too much about it, but I want to get you this before the poker project is due. Let's implement the interface. It says, hey, okay, here's a compare to. given a card, it returns an integer. And we don't need this throw. We're not actually throwing anything right now. We want to actually go do this thing. So what compare to does, right, it says it gives a negative, or returns negative value if it's less than other. I like other instead of O. 0 if they're even, if it's even or equal. And equal is kind of a term here, and then positive if it's greater than other. So in our case, how do we compare two cards? Well, two cards are equal, right, if their face value is the same. We don't care about the suit right now. So we're just going to do the face value. And we need to have suit in our card class later, and these should be enums, and you can use the enum ordinal values and all that good stuff. But just for the quick example, we're going to say if my face, we're going to return face minus other face. Okay? Oh, I'm sorry, face minus. Sorry, not less than, minus. So I take my face value. If it's 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 11, 12, 13, 14, really is what you could use for jacks, queens, kings, aces, if you wanted, and subtract the other's face value. So for both 2s, we're going to give back 0. We're essentially equal, right? We're equivalent values here of cards. If I'm a 5 and there are 2, it's a positive number, which means I'm greater. That's good. And if I'm a 5 and there are 10, it's going to be a negative number, which is good because I'm less than. So if I have this compare to method here, then I can run array sort on an array of cards. And that's the magic here. I had an E in compare, like compare. Okay. I'm bad at stuff like that. So cards pre-sorted, 2, 5, 7, 3, 3. Post-sort, 2, 3, 3, 5, 7. So if we take advantage of this compare, to compare one card to another, you can just compare their face values. Again, use the ordinals, right? And because enums just have that ordinal value behind the scenes, we could do that. But I wanted to show you how this could work to make that sorting piece a little bit easier. Okay, because then if they're in sorted order, it's going to be a little bit easier for us to compare some of those hands. Right, again, let's just go take a look at the list of poker hands here. And I know it probably sounds like a big project all at once, but you want to break it down into smaller and smaller and smaller pieces. Do that functional decomposition. Right, let's solve one problem at a time. Right, so with hands, the first problem we want to figure out is how do we determine if a hand is a straight flush? That's one problem. How do we determine if a hand is a 4 of a kind? How do we determine if a hand is a full house? How do we determine if a hand is a flush? How do we determine if a hand is a straight? And you can break all those apart into separate pieces here. Like, is this hand a straight flush? Is this hand a 4 of a kind? Is this hand a full house? You can just return a true or false sort of thing. Right? So the poker hand, right? Use a rank enum. Again, this just makes life easy. I have a bunch of enums, right? I can be an enum for high card. I can be an enum for 2 pair, for 2 pair, for 3 of a kind, on and on and on. Because that way we get nice names for things, right? Enums are great. We like enums. We're using them a bunch for this project, right? If my rank is not the same, the higher rank wins. So that's a great start, right? So don't use this rank number, right? We want that opposite, right? You want straight flush to be the high rank number because that means it's greater than, it'll work, right? If you can figure out which rank you are, great. That's most of the way there. Right? Do one rank at a time. How do I figure out this? How do I figure out that? How do I figure out that? Figure out what rank the hand is. Then you can worry about tie breaking. Right? When we say, hey, take one hand, compare it to another. So a method like, I don't know, wins, or even like another compare method sort of thing, that we're going to return an enum for win, lose, or draw. Did we win? Did we lose? Did we draw? What happened here with poker hand? What was the result compared to another poker hand? So if they're different ranks, it's really easy to calculate. If they're the same ranks, then we can start worrying about doing tie breaks, right? And we can do those one at a time. Well, how do you tie break a straight flush? It tie breaks the same way a straight does, right? The highest card wins. If they both have the same highest card, then they're equivalent. Right? It's a tie. 4 of a kinds. Whoever has the higher 4 of a kind wins. So if I have a 4 of a kind of aces and you have a 4 of a kind of 3s, my aces are better, right? Ace is high. Okay? Whoever has the higher, and you can't tie because there's only 4 cards, right? 4 of the same face. So if I have a 4 of a kind, I have all of that face. So there's no ties. You don't have to worry about ties and 4 of a kind. In a full house, whoever has the better 3 of a kind wins. And you both can't have the same 3 of a kind, right? Because there's only 4 faces, again. For flush, it's one card at a time. Whatever the highest card is, if those are the same, look at the next highest card. If those are the same, look at the next highest card. If those are the same, look at the next highest card. If all 5 cards are the same value, then they're equivalent. If not, whoever had the first higher card wins. with a straight, right? Whoever had the highest card. 3 of a kind, right? We already talked about 3 of a kinds. 2 pairs, right? You need whoever has the highest pair wins. If both the highest pairs are the same, look at the next highest pair. If those are both the same, then look at the last card. Whoever has the highest last card wins. Maybe they're equivalent. 1 pair, same thing. Look at the 1 pair. If your pair is higher, you win. If not, check your other 3 cards. And then with high card, check your highest card, check your next highest card, next highest card, next highest card, next highest card, on and on and on. Okay? So you just work your way down and just do them one at a time, right? Don't worry about tie breaking everything. Tie break one thing at a time, right? Or pick out the rank one thing at a time, and then figure out how you tie break ranks when we compare for win, lose, or draw. So it sounds like a lot, but we're able to break it down into smaller and smaller and smaller pieces here. And, I forgot to add the rubric. So if you give me a second here, let me go grab that rubric, because this will make my life a lot easier to not have to copy paste this stuff in. So I've got it for the other class. I just didn't attach it to your guys's yet. So let's do this. And while I load it up, I'll tell you a story. Do you guys, any of you like to go fishing? And you go out on the boat in the lake somewhere and just sit peace and quiet and fish, and whether anything bites doesn't really matter. You just go out for the fun of it. Well, I was out with some buddies, and one of them, it's supposed to be boring, right? I mean, that's the entire goal of fishing, as I understand it, is to be boring. I've never thought of it as an exciting thing. We go rubrics. So we were out fishing, and one of my buddies is a smoker. Whatever, it's his own choice. I don't smoke, but if he wants to, he can. But he apparently forgot to bring his lighter. So he was asking the rest of us, hey, do any of you have a lighter? And I said, well, no, I didn't bring one, but here, do you have any cigarettes? I know, I recycle jokes. I'm sorry, Crow. I don't have enough to tell fresh ones every time. So I said, well, no, I don't have one right now, but do you have any extra cigarettes? And he said, yeah, here, I've got a pack. So I took one and I threw it off the boat. I said, here you go, the boat's a cigarette lighter. He was not amused. Yeah, I forget some people have more than one class with me. I'm sorry, but you miss out on some of the unique dad jokes. All right, we'll go import the rubric. All right. And then I can attach the rubric, and then it should all work nice. I'm so sorry, King's Assassin, or King Assassin. That is unfortunate for you. I get sick of hearing my own voice. I can't imagine you guys sitting through more than one class of mine. I don't need those. There we go. Import. Oh. Okay, so you're not, okay, so you hang out in the classes, but you're not a student. I gotcha. I thought you had enrolled in more than one class of mine. I was feeling bad for you. So, you're here by choice, and you get all these dad jokes. Oh, you poor person. It's all right. I had a colleague from work. You can tell I'm growing this ridiculous beard. I'm winning a bet, by the way. Though, I had challenged Dr. Baugh when I found pictures of the monkey tail beard. I thought it'd be hilarious, and I challenged him to do it. And I said, I'll donate $100 to the charity of your choice if you grow this monkey tail beard. And best I can tell, he has not taken me up on it. But after I got thinking about it, I'm like, you know what? That sounds like a lot of fun. So I want to try it. So I started growing it. And then, of course, I hit him up. I said, hey, we got this big discipline meeting. All the CIS profs are going to get together tomorrow. I said, if I keep the beard until tomorrow, this was like a week ago when it was really bothering and itching me. I said, well, you donate $100 to the charity of my choice. They're like, okay, sure. You talked me into it. So I'm keeping it. But a friend of mine told me this is essentially the dad joke of beards. And now I want to keep it forever. That made me so happy. That's going to be, shoot, that's a little hard to see there. That's okay. It's not too bad. So here's the rubric for it. Okay? So 15 points, right? This is worth 5 points more than the last project. And again, the points are only important within the project's category because the category has a certain weight. Okay? We got chemistry and AP computer science principles. Nice. So your card class has enums for face and suit. You get 1 point there. Your card class has the copy constructor for 1 point. Again, it's kind of silly, meaningless, pointless to have the copy constructor. I just wanted you to do one with a basic class where it's not going to be super complicated or crazy. It might have made more sense to do it for deck, but don't worry about it. It's okay. We're just going to do an easy one in card. Okay. The deck class can give a random card from the deck. Right? When you create a deck, it should load itself up with 52 cards, put it in like an array list, and then when you ask for a card, it should pick one by a random index and give it to you. Take it out of the array list. Right? That way it has 52 cards, and it has 51 cards, and 50 cards, and on and on. It should be able to deal all the cards. We're only going to use 10 at a time, but then we're going to make a new deck every time. The poker hand constructor, we accept 5 cards and stores them in sorted order. I mostly gave you that, right? The sorting piece at least. You do have to fix up cards, so it uses enums and sorts using the face ordinal, but you should be okay there. And then 1 point per rank. So if you get a straight flush hand rank with a unit test, right, for your tie breaks or whatever we're doing here, whatever we're comparing in straight flush. Again, we want 100% code coverage, so the unit test needs to cover if you have a tie break condition, make sure that it goes into that tie break condition. If you don't have tie breaks, right, maybe we don't go into it. That sort of thing. So a point for straight flush and unit tests, 4 of a kind and unit tests, full house and unit tests, flush, straight, 3 of a kind, 2 pair, 1 pair, and high card. So 9 out of the 15 are for getting the hand ranks and unit tests done. Okay, again, break it down piece by piece by piece. You don't have to tackle it all at once. Right? Then $1 for the actual game itself, where the player can raise $1 or call, and the computer just randomly accepts the raise or fold. I think I said just to give it a 50-50 chance. Yeah, pick a random number, fold 50% of the time. Okay, so like sometimes they'll take it, sometimes they won't. They are not smart at all. We can work into smarts later. Okay, and then the game just keeps running until a player runs out of money or quits. Okay, I think that's everything from the description here. Moved over to the rubric, so you know exactly how you're going to get your points for it. And there are partial points, right? If you don't get all of them, that's okay. You'll get the points for the things you did accomplish. Okay, so like without any of the poker hand stuff, if you just have the game and you have a deck class and you have cards, you can get 6 out of 15 points. Okay, that's how that works. If you get just the poker hand class and none of the other things, you can get 9 out of whatever. Although you're probably going to need card, right, to do a poker hand. So, but there you go. So that's how we get all the points. Okay, that sound all right? And we've got the ways of sorting our cards to implement this comparable. Again, we'll talk more about what that means in Chapter 10. We'll get into interfaces and abstract classes and all that good stuff. It's really fun. I promise. It's good stuff. Okay. So do work ahead, please. When you have questions, get stuck on something. General questions, please post in the class Discord channel. A couple of people have already been there. That's fantastic. I love seeing questions there. Because it's like we're in a real class where if someone asks a question, everyone gets to hear the question and the answer. That's a great benefit for everybody. If it's something specific to your code or an error you're getting, email this direct message in Discord, and we can go from there. Okay? Yep, so we'll get into more of what that stuff is and why it makes sense here, but I wanted you to have that tool for the project. To make a class versus just making a function. So it depends on the problem you're solving. Yeah, so a class is typically a noun where you have to worry about its attributes, where you have that data, right? And if you have a way of interacting with that class, that would be a public method of the class. So it's all about object-oriented design, right? Functions, it's great. They'll just do a job. That's okay. If it's you take something in, you spit something out, that's nice and easy. It's just a function. But if it has to do with your attributes or data or specific to your instance, then it's probably going to want to be a class with a public method, that sort of thing. And you could go overboard. We could go absolutely nuts with this and have classes for everything. Someone had asked, like, the game portion of it. Do we need to have a class for the game that has players and that has, how much money you have? And that's probably overkill at that point, right? You could just have some player dollar amount and computer dollar amount as values in main. And that's probably okay. If you wanted to make a player class and a player had a set of money and player could have a hand and this sort of thing, you could do all that too, but it's probably overkill at this point. Right? There's such a thing as over-designing your solution, which is one of the reasons object-oriented programming gets a bad name sometimes. All right. And then after that, we'll do some midterm review and have the exam. So the plan is to spend the time doing the review and then let you have the rest of the night for the exam. If you want to take it early, you're welcome to do that. So like if you want to stick around for midterm review, I'll be doing that 6 to whenever you guys run out of questions on 3/11, and then the midterm won't be due till midnight, 2 in the morning, sometime later that day, assuming you'll take it that night. Maybe I could leave it open Friday as well, if you really want, if you're a morning person, sort of thing. But I've got to have a window there for the exam for everyone to take it. So maybe it'll be available Thursday and Friday, perhaps. And this one will be a timed exam to level the playing field in case people have more free time than others. It'll have a 2-hour time limit. So once you click start on the midterm, you'll have 2 hours to hit submit. That way everyone gets the same amount of time on this one, rather than the quizzes where you just come and go. Okay? And then we'll pick it up, and we're getting close. Our final project, remember, if you want, you can do this in pairs with a classmate, but I'm not going to require it like I usually do, given our remote learning environment. That just seems cruel and unusual. So I'm planning on not doing that. But if you want to, go for it. You can pair up with somebody, and we can go from there. No picking up ringers. Oh, King's Assassin, thank you so much. I forgot my backboard here. I'm slouching again. You can tell like I get farther and farther and farther away from the screen. Let's try this here. See if it helps me sit up a little straighter. Whew, although I hit my head if I sit up too high. Okay. So yeah, no getting ringers like people who are just hanging out here in Twitch but not in the class. They're not allowed to be your partner. I'm sorry. Okay. Not usually. I mean, the work is still pretty much the same. It's not harder if you want to pick up a second person to work on it, because it has its own set of challenges with coordination and dividing up the work and collaboration sort of thing. So usually it takes about the same amount of effort to do it in a pair as it does solo. Teamwork is much more interesting. And you usually get a better product out of it because you can talk about your ideas with somebody else and bounce ideas off of each other. And in that design process, you find where you have problems before you even write code. And then you're all frustrated and trying to debug your code. And, oh, I don't know why it's not working, because you just designed it badly and it won't work. That sort of thing. Yeah, so I think that ought to work. Okay, so we got chapter 9. So that was the card class there. Okay. So let's see. Other cool things that happen. Let's take a peek here. Make sure I'm not getting too far off the rails. So this idea of wrapper classes. We've worked with primitives before, and we've actually done some of these wrapper things. So you have like ints, numbers 42. You might have a double value 3.1415926. I forget how far it goes. That sounds pretty close. You might have a character, like an individual character, like A, right? You might have a Boolean value, like is tired, and we'll say true. Right? These are all primitive types. So these like orange ones here are the primitive types. Not all orange, but like they're all, character letter. There we go, a name for it here. Told you, is tired is true. So these are primitive types. Java comes with wrapper classes that give you more features to the primitive types. So remember, with a primitive, what we're actually storing in memory is the value. So the letter A, wherever the letter A points in memory, is the value of A. With reference types, it doesn't work like that, right? So when I have a string, I don't have any strings or other reference types. String name is Eric. What the value of name stores is where this thing is in memory. So it's a reference to the memory address where Eric is actually stored. So Eric is not stored at the memory address where name points. Name points to the memory address where Eric is stored. Yeah, you guys please ask questions about all the projects. Right? If you're stuck on something, please ask. But my goal here is to help you understand the material and apply it. I'm not going to write the code for you, but I'm decent at helping you figure out where you got stuck and what's going wrong. And I'd much rather work with you to get your problems fixed than for you to turn something in and say, oh, it didn't work. I don't know, I felt so bad. I had one person stay up like all night long, and I got an email at like 8 in the morning when something was due in a couple hours. They said, I stayed up all night and I got stuck on this, and I don't know what's going on. It's not working. And it was like a 2-line fix. They just had 2 things wrong in one spot. And I pointed it out right away, and they said, I stayed up all night long and I couldn't figure it out, and I just felt terrible. So like try for a good half an hour to figure out your problems, see if you can find out what's going wrong, read the errors, try and understand what it's telling you, and then reach out if you're stuck. Right? It's not worth you spending hours and hours and hours just banging your head against the wall, getting frustrated and mad and angry. As then you're just going to be frustrated and mad and angry at the class and at me, and the odds are I can usually fix it for you in 5 minutes or less. It's not always the case, but I have pretty good odds that I can fix it in 5 minutes or less for most things that you guys run into. Right, and I'm happy to point you in the right direction, okay? So name is a reference type. So what name stores is the memory address of where Eric is in memory. So they're separate. So you have a variable that stores where to go get this thing versus what letter is in memory is the value of A. Okay, so we're actually storing double. So every time you have a reference type, you're storing a 64-bit memory address, which then points to the other thing somewhere else in memory. So it takes up a little extra space, but it's okay. We like reference types. That's the way things work. But because they're reference types, we can't do anything with them, right? Like there's no number dot. Right? But with name, because it's a reference type, it's a class here, name dot, and I get all sorts of cool things. I get all sorts of cool things. There we go. I don't know why. Okay, it's just one of those days. These are all the methods I can do because string is a class. Right? It's the java.lang.string class. All of these are cool things we can do with strings. We're going to get into these later today with the text processing. You can do all those things. So what Java does, it gives you a wrapper class. So we can have a capital I integer dot. These are all the things we can do with integers. And it's not tons and tons and tons of things, but one of them is parseInt. Right? Where we've done integer.parseInt to get some keyboard input. So it's using the integer wrapper class here because it has methods. Now, the other thing we get with wrapper classes and primitive types is they're essentially interchangeable. So I can say integer, so my number equals 42. So say, hey, here's the primitive type, assign it to the integer type, the class type here, my number. Java doesn't care. So this is called boxing. It takes the primitive type and puts it in a wrapper box so that you can reference it by type. Again, my number doesn't do anything here because there's nothing on an instance of integer. It's not as interesting, and we can do it the other way around. We can say, int my other number equals new integer. Remember, use the new keyword when you create new instances of something, integer 42. And NetBeans is even telling me, hey, this is silly. It's unnecessary boxing. We don't need to box a primitive type into the class type. We don't have to do that. No big deal. Okay, we can do it either way. Okay, so that's the wrapper types. And all those types let you do cool things, right? So like boolean dot, no, is it bool? Yeah, boolean. There we go. I don't know why the dot thing's not working for me. It's just going a little slow. Oops. Dot. There we go. We can get other things out. You can do some cool stuff with it. Okay? So those are all the wrapper classes. They're handy. We've used integer, we used double for double.parse, double integer.parseInt, those sorts of things. Okay? And all of our wrapper classes are immutable. So like if you go and reassign it, it's not changing the value, it's creating a new one. So sure. So like character has a bunch of cool ones for processing characters. And then strings have lots of fun stuff. Strings are really cool. You can do a lot of cool things with strings. Hydration, thank you. Yeah, let's get out the coffee here. Oh yeah, that's good stuff. And this thermal one is nice. It's still warm. It's been on my desk for a while. Integer of 42. Let's see. So boolean compare integer of 42 equals 42. Integer, new integer. I think this would work. Let's see. Let's find out. Let's put a breakpoint in here. Let's run it. I think it does the auto unboxing, so it'll take an instance of integer and then unbox it back to an int type. Oh, I ran. I should debug. That'd be helpful. You know, put a breakpoint in and actually debug it. Don't put a breakpoint in and run it. Don't do that. Don't be that guy. Come on. Let's take a look. All right, so I got some variables. All right, so let's see. So let's step. Compare then is now true. Yes. Yep, it works. Yep, so it's going to automatically unbox it back to the primitive type, I think, to do the comparison. Yep. Yeah, I mean, so you'd never use dot equals anyway, because we can just use the equal sign for primitives. It just works. Okay, cool, that was a good question. Yeah, strings you want to use equals because strings are reference types. Remember, with reference types, the equal sign says, are you the same location in memory? Which sometimes is what you want, but not all the time. Right, so string other name equals Eric, and then let's print name equals other name. Okay. They should not be equal because they're going to be in different locations in memory. Yep, they're not equal because they're in different locations in memory. So when we create another instance here, it says, oh, you want a new one. Yep, but if we assigned one equal to the other, they would be the same. They'd be the double equals here. Right, again, double equals for references. Here's if memory address is the same. So that's like, you might have an alias, sometimes we call it, if you have two variables pointed at the same location, that's an alias too. So I can tell you if that's an alias of another. Okay, so substrings are really cool. So I might have, like, say, name Eric Charneski. Okay, and I'll put that in over here too. So keep it the same. Twice in a row, I spelled Charneski backwards. That's so sad. It's so sad. Should be able to type my own name by now. Okay. So what you can do is, if you only want a part of the string here, I could say this is my string last name is name.substring. And substring, you get two options. You can either give it the starting index and it will go to the end, or you can give it a starting index and it will go to the end, not including index. The reason that's useful is you can say length, right, to go to the end, and it will stop one before the length, because remember, the length of a string is one more than indexes it has, because indexes are zero-based. So in Eric, I have indexes 0, 1, 2, and 3, but the length is 4. List of integers. So lists have better a default for outputting, like a two-string. Lists have a better two-string than arrays. Arrays don't know how to two-string themselves. So if you were if you were to call system.out.println on an integer array, it wouldn't know how to two-string itself. So it gives you the memory address, which is that hex address, hexadecimal value, versus the list itself is going to be a little bit smarter. So substring here, I could say, let's go from, say, I want index 6 here. That should be the C. 6 to, again, we'll just leave it off. We'll just say start at 6 and go to the end. And then we can print out the last name. Now, again, that's a little bit silly because, like, to know where the 6 is a little bit awkward. We'll show you some other things in a second. Almost always. So arrays are technically, they use less memory because, oh shoot, I did it wrong. I don't know how to count. That's right, index 0, 1, 2, 3, 4. Oh my goodness, Eric. It's the 6th character, index 5. I just told you guys it's zero-based. So yeah, an array is a little bit more compact because it doesn't have any of that reference stuff. It's not an instance of a class, so it's ever so slightly smaller. But that's the only reason that you might want to use it if you are, like, super optimizing the amount of memory you use. Other than that, your list class, array list class, is so much better. Like, it's just so much better, so much easier to use, much more friendly. I would always recommend you use that instead of a regular array. I think arrays are stupid. Okay, so index 5 should be the C for Chernesky. There we go. Chernesky, there we go. Okay, so I get the last name. Now again, that's, how do you know that substring was there? Like, to find index 5, that's a little bit tricky. Yeah, so this is start index and then goes to the end, unless you tell it where to stop with an ending index number. So what we could do is we could say, maybe enter your name, and then we'll check to see if there's a space in there. So let's say enter your name, and then we'll use scanner keyboard equals a new scanner, given system in. Excuse me. And then string input name or something is keyboard.nextLine. Yes, I want to import scanner. Thank you. So 5.8 would give you, starting at 5, index 5, it would give you index 6 and give you index 7. It does not include the last value that you give it. So it is inclusive of the start, exclusive of the end, which is really obnoxious. But most of the time when you type in substring, it tells you. I can say input name dot substring, and it's going to tell me here that it extends to index -1. It's like helper text is amazing. And this is all JavaDoc documentation. So I don't mean to bash the JavaDoc comment thing. It's super helpful and useful, and I'm so glad people do it. But I don't want to teach you and waste time telling you to do that sort of thing when I don't actually care, right? You can learn it after. I'm assuming you guys are smart people who can learn this stuff. Okay. So if I want to check then, see if they entered something, I can look and see. So I can get, say, the int index of space is my input name dot index of a space character. Say, hey, did you enter a space? And index of is going to give you back the index of the first occurrence of this character, or negative if it doesn't exist. So I can check if index of space is greater than 0, then I can go do something. Right? Then I'm going to assume you have first name, last name in here, right? So then maybe, again, I'll define them out here. Maybe I'll say string input first name and string input last name. Just start off as empty, so then I can sign. So if there's a space, then we'll say input first name is equal to a substring. I'm sorry, input name substring input name dot substring. And I want to go from 0, and I want to go up to the index of space, right? Because I want to stop not including the space. So if I enter Eric Chernesky, right, it would tell me space is index 5. No, I'm sorry, index 0, 1, 2, 3. It would be index 4. So I want to stop at index 4. So give me index 0, index 1, index 2, and index 3. Okay? And I'm going to assume then your input last name is input name, input dot substring, and I want to start at index of space +1. And I want to go to the end. So I don't need to give it an ending substring. So wherever space was +1, go to the next character, and let's see what we get. So then we'll print first name, last name. First name, and last name. The last name. Okay, we'll see if we find anything. And if they're blank, right? So if you don't enter a space, we're not going to have first and last name. We're just going to have a regular name. Right, so maybe we check in here. So maybe we say if input first name equals empty, or input last name equals empty, an empty string. I think, wasn't there a better way to do that? Dot empty is empty. There we go. So if it is empty, that's better. Is empty. So is empty is going to tell us if the length is 0. There we go. That's probably easier than checking to see if it dot equals something else. So if they're empty, do one thing. Else, if they're not empty, right, we'll print first and last name. Able to determine first and last name. Okay, so let's see what we get. So if there is no index of space, we just don't do that thing, right? Enter your name, Eric Charneski. So first name, last name. Good, that works so far. Let's try it again now with not a space. So enter my name. If I just give it, oops, here we go, Eric, then unable to determine first and last name. Okay, that's what we get. So again, substring is really cool. And you can find stuff based on index. You can do all sorts of fun stuff with it. An index of can also tell you like which, you can give it a starting index. So like you can count the number of characters in a string, but that's the hard way, right? There's easier ways to count. Name dot, I think it's just count. No, it's not count. It's contains, no. There's something in here. Where is it? I'll tell you how many times it's in there. I thought it had count of. No, I'm not seeing it now. That's annoying. Okay, sure. Index of, sure. You can give it a from index if you want. So maybe we'd have to count that way. That sounds terrible. Yeah, Python has it. I'm spoiled with Python. I do love Python. It's probably my second favorite language. Oh, sorry. Oh, good. That was empty. I did almost spilled it over my computer. All right, so we did substring. Oops, that's the wrong window. Sorry. I'm trying to follow along here in the slides. Make sure I got it all here. You can check starts with or ends with. Similar region matches is to see if those places match in a string. Sure. Index, last index, searching. Yeah, those are all fun. Getting substrings out. Yep. You can turn a string into a character array, which is fun. Trim is really handy. Trim will take off any leading white space or ending white space. So trim is really handy to use off of inputs here. So if I do the next line dot trim, it's going to take out all the extra spaces here. Because before I were to trim here, oh no, C++. I am not a fan of C++ at all. My favorite's C#. So if I had like space, Eric, space Charneski, space, and I would have a bunch of extras, but now I don't here and I don't at the end because I trim clears off all the leading and trailing white spaces, which is really nice. Okay, so trim's handy. What else do we got? Replace. I think we did a replace thing before. You can get values of characters. That's all fun. All right, yeah, we got string builder coming up. We'll do string builder. What else do we have? And splitting, good. All right, we already did our wrappers and parses. Okay. Awesome. Yep. So we are almost done now. We've got some string building to talk about and splitting to talk about, and then we will have some time to work on the project. Okay, so why don't we take a break right now? It's getting close to 7, and we'll take about 10 minutes or so. Go stretch, get some dinner, whatever you got to do. I'm going to go get some more coffee. Deconstructors are fun. We can do those in Java. There's a finalize method in Java that will garbage collect or help garbage collect your class. But again, you don't have to worry about it as much usually because it's a managed environment. So why don't we take 10? We'll come back and we'll pick it up with the rest of chapter 9, and we'll go from there. So if you have questions about the project, bring them when we come back from break. I'll be happy to answer specific questions you folks have about the project. I'm sure everyone will benefit because if something's not clear to you, I can guarantee it's not clear to someone else. Okay, so I encourage you to ask questions, and we can go from there. All right, so I'll put some more. Did you like that, like the heavy metal alternative, whatever they called themselves, or do you want more just the electronic stuff I was doing before? Do you have a preference for music? I can do either. I only have so many DMCA free options nowadays, so I have to do stuff they're not going to flag my stream for, YouTube's going to flag me for. All right, let's go for it then. Let's put that back on, and we'll go from there. I'm just pulling off their music off the SoundCloud right now, so that was easiest. All right, you got it, Mark. You voted. People who vote get to pick. Come on. It's like super slow when I'm using OBS for some reason. I think try this one. All right, go back in 10. Hey gang, welcome back. Alrighty. So we're going to wrap up the rest of chapter 9 here, and then we'll be good to have some time to get started on project 2. Hopefully you've already had a chance to get started, but now really bear down and get this thing done. Again, if you've got questions, reach out, but if you wait until next Wednesday night, my time is very limited, unfortunately. And Thursday is the craziest day I have with 4 classes back to back to back to back to back, with just time to like eat in between. So I'm like eating on break and stuff. Thursdays are rough, but that's okay. It's all good. It is all good. So let's finish up chapter 9. We're going to talk about string builder. So string builder is amazing. So if you recall, strings are immutable. So if we were just to say for a bunch of values, so like int I don't know. Sure. Index is 0. I don't like that. Int value 0. Value is less than 10. Value plus plus. I don't know. Why not? Did I already use value? I already did use value. That's fine. We'll just redefine it. That's okay. Sure. If we were to say enter something, and then out here we'll have like a string for result is an empty string. Uh-oh, I just got a networking error. Oh, bummer. Okay, I might be back. That was quick. I'm refreshing. Let's see. Maybe we're back. It's my luck, right? Come on, Comcast. Work with me. Work with me, Comcast. Okay. It's reloading. Maybe. 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 Guess I did go back to there. Let's see. See what we get. See if I can even chat. Okay. All right. It's just loading real slow on my side. That's crazy. All right, sorry about that. Yeah, so if you remember, adding to a string, right? Plus equals keyboard.next line. And then we said, like, I don't know, this is value plus that thing, plus a colon, I don't know, just something to make this look a little prettier. And we just keep on appending those things, and then when we're done, we spit out results. Yeah, not useful at this point, but we would add to a string over and over and over and over inside a loop to get some sort of result when we're done. Let's see if we can get that. Okay, enter something. We just give it a bunch of nonsense 10 times. Okay, there we go. So 0, 1, 2, 3, 4, on and on and on. Okay, so we get all that nonsense in a row. But every time you append to string, remember, because strings are immutable, it builds a new string in memory. So it has to copy the original, add in this new thing, and then save it somewhere. And copy the original, add in this new thing, and save it somewhere. So this is terribly inefficient. Inefficient to repeatedly copy to strings, or append to strings. Do string concatenation, because it creates a new one in memory every time. So the better way to do it is to use something called string builder. So string builder uses a buffer behind the scenes. This is a string builder. It's a new string builder. And you can tell it, like, if you know about how big it is, like about 100 characters, you can give it a size. I almost never bother, unless it's like really, really, really big. Okay? And we can do the same thing here now. But now inside of here, what we want to do is we want to take our string builder, and we want to call append. Builder.append, and we can append a bunch of things. So we'll append the value, and then we can append, oops, builder append in that, like, the colon separator here, and then we can append in keyboard next line. You might have to refresh software. Refreshing. Sorry, every so often it gets a little silly like that. Okay. I'll give it a minute if people need to refresh. So there's not much of a crowd at night either. I think a lot of people are just doing it asynchronously, which is fine. Or maybe they come in the mornings, but I'm happy to be here and chat with you folks who are here at night. I did night classes all through school. That was what I did and how I got through it. So I'm used to the 4-hour block night classes, but it can definitely be long. So I'm glad we're able to cut it a little bit shorter since we don't have the lab time. But I do miss being there in the lab and be able to walk around and help you guys with projects. So we'll make do with Discord and screen sharing and Zoom and whatnot. So sorry it's not the same as being in person, but we're trying. How are your other classes going, by the way? Just curious. I do try and typically reach out and make sure that this format still works well for people, because we're not a discussion-based class, so typically Twitch is okay. And I've had people say they prefer this to Zoom, and I know like Zoom gets really funny when a bunch of people have webcams on anyway, and the lag in Zoom is terrible too when it cuts in and out. Not that Twitch doesn't lag at all, but you know, that's just my preference. So I'd like to keep using this platform as long as no one says it's terrible. But do let me know. Yeah, my sister-in-law is back in school, trying to finish up and get into a graduate program. And she's been doing Zoom classes out at Eastern, and she said it's been rough. So, but I mean, she's getting into social work, so like a lot of the classes are discussion-based and like let's discuss a topic rather than this lecture style where I just get to talk at you guys and show you cool code. So, you know, I think the format depends as well. This definitely wouldn't work as well for a discussion-based class, but thankfully it's not a problem for us. So this is bad, appending strings, because we just keep creating new strings in memory. Right? This creates a new string in memory every time it changes. Okay, so that's bad. So we're not going to notice the difference because we're not doing anything at some ridiculous scale. But anytime you're getting, you know, thousands of operations or going to some large scale, it's going to make a big difference. It's hard to not get distracted. You just open another tab. I mean, don't you do the same on Zoom though? And then flip back over to your favorite subreddit or something? You know, do you like when people sit there and make sure you're watching the Zoom cam? I can't do that while teaching and talking. Like, look at every single Zoom camera and see like what's going on. Oh yeah, online learning. Yeah, online learning is rough, for sure. I have trouble getting through online classes, especially asynchronous classes. It's just not my style. So I much prefer the synchronous interaction. But that's my learning style. I know everyone learns a little bit different. But I am hoping to continue the recordings when we come back to in-person. I don't know if I'll keep streaming live on Twitch, like streaming while I'm doing the stuff in person. But for sure I'll keep doing the screen recording capture with OBS, and I can post the videos to like a private YouTube or something. There's other issues with background conversation that comes up, and I'm not allowed to say any of your names unless you say your own name. Because sure, I mean, you're adults and you can choose to do that yourself, but I can't put your information out there online. So it's just a little bit trickier when I'm doing it in person. And I've gotten away with it in the past, but so maybe I'll keep doing it. But all right, cool. I'm glad that the format's working well. Again, do find me on Discord. We can do screen sharing stuff. We can hop on Zoom. We can do those sorts of things. So it's close to helping you in person, where I can see your screen and look at your code and see what errors you're getting. And usually that works out relatively well. So, okay. So string builder is better than appending strings because it doesn't make a new string in memory. Right? It's a class here that does some cool stuff behind the scenes. It uses a buffer and all sorts of cool stuff. But when it appends, it just keeps on adding. So the buffer has space to keep on storing things. And then when you're ready for it, it can combine all of it into a single string. So then we can just S out. And you just say the string builder. If you want, you can call toString, like to get the string out. But remember, if anything we put in print line is essentially already calling toString, is it saying, oh, you want to print something to the string to the console? Let's ask for the string version of it. So toString is redundant. Like it's happening automatically. So this will be much more efficient. We'll get the exact same result, but it's going to be efficient because it doesn't have to make 10 different strings in memory every time we change this thing. Right, so string builder is better. So string builder Builder doesn't have to create new string in memory every time it changes. So this is the preferred method, the optimization. Again, we don't care much about optimizations in this class. We're just learning the tools and techniques. But if you're going to scale something out and do it lots of times, yes, we want to optimize. Right? And we want to be efficient. So at this point, I'm just concerned with, can you get the job done? And I'm happy. Okay. There's String Builder. So String Builder is really cool. And you can do a lot of the same stuff. No, wrong window. A lot of the same stuff with it that you can with your other classes. You can get index of, you can find the length, you can do substrings, those sorts of things with String Builder as well, which is really cool. So just go ahead and keep on playing with it, doing all the string things you would do. You can insert into locations and whatnot, which is really fun. Yeah, String Builder. Yep. Okay. So before we had checked this first name, last name, that was okay. It worked out. But another thing you might do, right, is we might say like have a whole sentence, and we want to do something silly with it here. So let's ask for a sentence. So we'll out enter a sentence, and we will scramble it into a secret message. Okay, we'll scramble a sentence into a secret message. Right? So we'll get that message. So we'll have a string for message. It's keyboard.nextLine. Okay. And then what we want to do is we want to loop through this message, and we're going to take every other character, and we're going to stick them together, and then leave the remaining ones to go to the end. So like if we have the whiteboard here. We don't need our circular queue. That's not this class. Okay, so say we had like, this is fun. Those are spaces here. So we're going to take the T, we're going to take the I, we're going to take a space, we're going to take the S, we're going to take an F, we're going to take the N, and we're going to come back and get the odd numbered indexes, right? So that's even numbered indexes, 2, 4, 6, 8, 10. And then we'll get the even ones, and we'll get H, S, I, space, U. So that's a pretty good scramble, right? It has all the letters, but it's scrambled up. Okay, that's the goal. So what we're going to do is we're going to make a string builder. String builder for scrambler. Sure. Equals a new string builder. All right, and we're going to loop through the message. We're going to say for index is 0, index is less than message.length, index plus plus. And actually, I don't want to do plus plus. I want to do index plus equals 2. Right? We're going to add 2 every time because I want just the even ones. I'm going to take scrambler. I'm going to append my message dot char at index. Okay, or we could even substring if we wanted. We could do substrings. Let's do substrings. Why not? So let's do substring from index to index plus 1. Right, if we ever wanted to change this, we could like scramble 2 letters at a time and take 2s, 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 or 3s, 3s, some silly thing if we wanted. So substring might be a little bit better. And then we're going to repeat this now for odd indexes. Index is 1, index is less, append it. And then we'll S out the scrambler. Okay, so let's see if we get a T sufn H su U. Let's try it. Enter something. That's right, we just had to do a bunch of gibberish. I should just comment those out. We don't want these in here. We do it again. Oh my goodness. It's faster this time. There we go. Enter sentence. This is fun. T snif hisu U. I think we matched, right? Does that match? T I S F N H S I under U. Yep. Cool. So we scrambled. Okay. How about unscrambling? Can we unscramble it? So let's make a string. Scrambled is my scrambler Scrambler toString. So this time I need to call toString because I want to save it as a string, right? That way I can go through and do all these things. I guess actually I could get the substrings right out of the scrambler. That's fine. This is okay. So we're going to do the same thing, but now we need to do it differently, right? We need to go and take our scrambled message, right, and take the first one, and then take the middle first one, and then the next one, and the next one, right? So this is 0, and 1, and 2, and 3, and 4, and 5, and 6, and 7, and 8, and 9, and 10. So the trick is, how do I find the split point? Right? Because in this case, we have an odd number of characters. Right? Because indexes 0 through 10 is odd. That's 11 characters. So I think what's going to work for us is we're going to have a start index and an end index. So an int for, or even index 0, and int for odd index is going to be the length of my scrambled message, right, minus the length divided by 2. Right, so when we get integer division, the length divided by 2, if it's odd, so if it's 11 characters divided by 2, I'm going to get 5. And then 11 minus 5 will give me 6. I'm going to start at index 6. So 0, 1, 2, 3, 4, 5, 6. That'll start me at the right index. Okay, and then we're going to loop. We're going to say while the even index times 2 is less than the length of the scrambled message. That length. Right, and let's take a new, an unscrambled, so another string builder. Unscrambled. A new string builder. Okay. We're going to take unscrambled. Did I already have that? Why does it not like it? Oh, too many parentheses. Unscrambled append. I want to append. No, unscrambled.append. The scrambled message, that's substring, from the even index plus 1. And then I want to grab the right-hand side, the odd index side. Odd index plus 1. And I want to take my even index plus plus and my odd index plus plus. So I guess that could have been in a for loop as well with like multiple updates, but sure, that's fine. This is okay. Is this making a little bit of sense, what we're trying to do here? Right, we need to find that midpoint to find out which one were the odd numbered characters again and put them back in order. Right, and then when we're done, we can S out our unscrambled string builder, see if we get the message back. Oh, you know what? I forgot to comment these out. Let me comment these out here. These nonsense messages. I think I've got this option here. Is that my comment button? Yes, I like it. That's my comment button. Okay, so now let's try it. Is fun. We get this is fun. So I put in an even number of characters because it's actually going to break if I put in an odd number of characters. Let me try that one more time and show you where it breaks. Because learning to read these error messages is really helpful. Really helpful. Sorry, I keep slouching back. I'm barely in my screen now. There we go. This is fun. We get, string index out of bounds at line 124. Line 124, right? So here's the error. It happened in string, substring. Here's my class where it happened. Right? That was the error here. So 124. Right here for the odd index. We need to check if odd index is less than my scrambled dot length. Then I can do this thing. And again, always use the curly braces. Never hurts to use them. I know you don't need them because it's a one-liner, but I'm going to tell you should always use them. Hydration. Thank you so much, software developer. Drink your coffee. Give me those coffee emotes in the chat. Okay, now let's try it. So now we should work with an even or an odd number, because we won't attempt to get an invalid index. This is fun. Oh, that's not my name. Oops. This is fun. Now we get scrambled and unscrambled. Okay? So now I want to show you, what if we want to do this differently? What if we just want to scramble each word? Well, it turns out there's a really nice way to split things up as strings based on anything you want, really, but spaces are the most common. So I can say a string array of words is equal to my message dot split. And I want to split on the space character. Now, you can give split all sorts of cool things. It doesn't have to be a space. It can be anything you want. If you're working with comma-separated value files, CSV files, you can split on commas. You got all sorts of cool options there. But do be careful with CSVs, because sometimes you have data that does contain commas, and that's a whole other can of worms. But split is handy. Right? And then we'll give me each word here then. And so now what I want to do, I want to take this unscrambled thing, and I want to extract it as a method. Introduce a method. There we go. It is unscramble. I don't think that did the right thing. Let me undo. Nope. All right, I was wrong. Unscramble. That's my scrambled. Here we go. All right, I'll just do it myself. I'll just write my own method. So let's make a static string unscramble method. It takes a string to unscramble. Well, this is the scrambled string, right? Scrambled. There we go. And then what we're going to do is we're going to return my unscrambled unscrambled. And notice you can't return unscrambled, right? It yells at you. It says, hey, string builder cannot be converted to string. Because we said we're going to return a type of string, we need to call specifically to string. It's not smart enough to do that for us. Okay, so we have unscramble. We're going to do the same with scramble. Public static string scramble. Given a string, I don't know, let's call the message. Why not? We'll be consistent here. And then we'll have this here. And then when we're done, we're going to return scrambler to string. To string. Okay, cool. So now I can do my scrambler here. So my string scrambled is my scrambler method dot to string. Or, I'm sorry, dot scrambler given the message. We can print scrambled. Scramble, not scrambler. Scramble. Okay, so I don't need that here because I already have it. And then we can unscramble it. So we'll have a string for unscrambled equals unscramble given the scrambled string. Okay, so that should still work. So now what we can do, now that I have those as functions, we can do that word by word by word instead. Oh, a first starting language? I definitely recommend Java or Python or C#. A nice high-level language. JavaScript is okay too, but it does a lot of weird things. I guess Python does a lot of weird things too, but yeah, Java, Python, or C#, definitely what I'd recommend. C++ is more advanced. And I've actually never done straight C programming. A lot of embedded systems do that sort of thing. So if you're getting into like automotive or machine controlling sort of stuff, C or C++ could be really useful. Yeah, it's a lot of good languages for stuff. But yeah, I'm spoiled with these high-level languages that do stuff that Python doesn't either. So it's typeless, so you don't have to declare types. But you know, it's okay. All languages are good, but yeah, I think a high-level one is easier to learn with because you're learning the fundamentals of how do you break a problem down into step-by-step-by-step sequences without having to worry about too many of the details. Because that's the bulk of programming, is problem solving and breaking down problems. Okay, so split, again, will give me a lot of strings. So I can say, I'll have a string builder, this is, I don't know, scrambled words equals a new string builder. Okay, and then I want to say for string word in words, right, this enhanced for loop here. Let's take scrambled words and we'll append the scramble of the word for each word. We probably want to, after we do each word, also append in a space, right? Because when you split, you get rid of the spaces. So I'm going to append back in the space here when I'm done. And then we can print out the scrambled words. Okay, that's words. Is the message split? Okay, so let's try that. So let's look at the two different versions here. Let's give it a slightly different message here. So a name here, the sentence will say, the key is underneath the entrance mat. So the scrambled version, ooh, that's crazy here, but we unscrambled it okay. If we scramble each word at a time, right, we just mix up each word then. So is doesn't get scrambled, but all the other ones do. So this one is almost readable. It's not too bad, one word at a time. But now if we wanted to get crazy, then we could also S out the scramble of scrambled words to string. So take the string version of scrambled string and scramble that. So scramble each word and then scramble the entire sentence again. And see if that makes it any more gibberishy or not. I'm not sure it will, but it's okay. We can try it. Eric, the key is underneath the entrance mat. Sure. I mean, they both look pretty scrambled here. So I'm not sure if one is better than the other, but just to show you can split and do things with splits, right? Getting one word at a time, you could do some fun stuff. We could like count how many times, how many letters are in each word. We could do all sorts of fun stuff. So split is really useful. It's called like a tokenizer. It gives you each string token out of the original. All right. Cool. So strings, yep, and then wrappers. That's it for chapter 9, folks. That's about it. Don't forget to read the textbook, right? We don't assign a textbook just for you to have a paperweight, right? Although my calculus book is now my monitor stand for my second monitor because I needed to like raise it up 3 more inches. But it's not I'm not actively using the textbook. I just, my son has big dreams of starting calculus, but he's only in 7th grade math. He's actually a little bit ahead. We've been using Khan Academy, and that's been pretty good for math, but he's still not quite there yet for the pre-calculus primer that's in the beginning of the book. But I was showing him some of the cool stuff you could do in calculus, and he thought it was really neat, because, I mean, calculus is actually really cool. I strongly encourage you to take it. I don't know, it's whatever, algebra something or other. I don't remember. I'd have to look it up and see. I don't know what the name was. It's a bunch of different topics. They do some geometry, they do some algebra, they do some, I don't know, whatever other stuff. I'll help him out anytime he gets stuck on something, but all right, cool. So we are pretty good for the night. Yeah, it doesn't have a name, or maybe it does in Khan Academy, I forget. It's just like the 7th grade level. Yeah. All right, so I think we're all set for the night. Do get started on project 2. It was going to be due before you know it. Okay, so let me commit all this code to GitHub for you guys. GitHub. And then you can use any of it you need. If you want to, you need to change card, right? Because you need to use enums for face and suit. But it's essentially, I mean, this is the gist of it, right? And use the compare to with the ordinals for face, and you'll be in good shape for having cards. And then you can sort your cards in your poker hand, and that'll make life easier for those comparisons for you. Okay. Don't forget, we do a study group 3 times a week, which is amazing. We've had a decent crowd. Not actually a crowd, but a decent number of people showing up, which is good. So I'm happy to see that. But that's definitely a good place to go. Meet with your classmates between the morning class and evening class, and our awesome SI. who's very familiar with this stuff. So this is Chapter 9. I'll post the Chapter 9 quiz later tonight. Give you at least a week to get that one in. Yeah, I mean, it doesn't have to be early, but not late. How about that? So late is rough. All right. Cool, so we got that code out at GitHub for you guys to look at for an example. Bring your questions to Discord. Private message me, text me, call me, send me emails, whatever you guys need to get this figured out. Tomorrow I've got a meeting like all afternoon long. That's our discipline meeting, so I won't be around to answer questions quite as easily. But you know, I can get back to you as soon as I can, or multitask and essentially ignore the meeting. Awesome. Yeah. So if you guys run into anything, let me know. The poker one, it's not super hard, but there's lots of little pieces. Lots of how do I solve this part? How do I solve this part? How do I solve this part? Right, so take it step by step by step, break it into small pieces, and solve those small pieces. And then that's the easiest way to go about it. Okay. All right. If you guys don't have anything else, we can see if there's anyone else on Twitch, someone else in the Knowledge Fellowship. We can go take a look and see. A shout out for them. Hey, don't worry about software. It's all good. We will get these things figured out. Let's see. Ooh, do you want to see this guy who runs a little manufacturing shop in his garage? He's pretty fun. He does like some CNC work, some work on a lathe, does a lot of resin casting and pouring. Interesting stuff. Lloyd's Custom Fab. All right, so let's head over there. Oh, that guy. Which guy? I don't know. Yeah, so we'll head over that way, say hi. That's optional, just part of the fun of Twitch. And you guys take care, and bring me your questions.